The next thing that we want to talk about is quick sort. So every time that you call dot sort in JavaScript, usually it's calling merge sort. Sometimes it calls quick sort. And when I talk about that, I'm actually just talking about like this, right? Where it's you call, on an array dot sort, and it gives you an array back that is sorted, right? That's what I mean when I say like dot sort. Most of the time, it calls merge sort for the reasons that we talked about previously, which is it's stable, its average case scenario is really good, all those kind of things. Quicksort has some interesting properties, but it's better spatially in terms of that it uses less memory to do. So occasionally, engines like V8, at least it used to, I'm not sure if it does anymore, sometimes we'll call quicksort. It just depends. Okay. So it is another what we call divide and conquer algorithm. When I say divide and conquer, you can basically just replace that with recursive, right? Because you're dividing the big problem into smaller problems. It's divide and conquer. It takes a kind of a similar approach that it's going to break a big array down into smaller arrays, but it does so in a slightly different fashion. So let's talk about that. So let's say we have this array here of 4, 9, 3, 5. It's going to choose what's called a pivot, right? So a pivot is going to be the last number here, the 5. Everything that's smaller than the pivot is going to be put into a left array. Everything that's larger than the pivot is going to be put into the right array, right? So this is the pivot, 5. 5 has made the pivot since it's the last in the array, and then we're going to divide this into 2 arrays. 4 and 3, because they're smaller than 5, are going to be put into a left array. So 4, 3 get put into this array, and 9 is the only one that's bigger than 5, so it gets put into a right array. Okay? Then we call quicksort on this array here, 4, 3, and we call quicksort again on 9. Okay, so let's go down to 4, 3. 3 has made the pivot. Everything that is smaller gets put into a left array, which is nothing. And everything that's bigger gets put into a right array, which is just 4. Those both immediately return because those are both base cases, right? The base case is either length 0 or length 1, right? Because those are already sorted. And then what you do is you call concat on left array, pivot, right array. So in this case, the pivot was 3. The left array was empty array, and the right array was 4. So it's left array, which is blank, nothing, pivot, which is 3, and then right array, which is 4. Okay? So then this returns 3, 4 from this quicksort call here. And then we have 9 here, right? So this is going to be this one here. Base case returns 9. And then up here, we're going to call concat on left array, 3, 4, pivot, which is 5, and then right array, which is 9, so we end up with 3, 4, 5, 9. Kind of clever, right? So unlike merge sort, we're only going to have one function. The one function is just going to be the quicksort function. That's it. And that's basically the whole thing. That's what quicksort is in a nutshell. I've kind of found this for you, which is a visual representation of it. It is actually possible to do quicksort in place without actually breaking it down into separate arrays, which gives it much better spatial complexity. Don't worry about that today. Today, just use all the arrays. Let's go, hog wild with all the arrays, because this is easier to conceptualize. But just know that it is possible to do it in place. So one thing I wanted to call out here, which people kind of find confusing, notice when I do the breakdown here from 4, 9, or I make 5 the pivot, and I have 4, 9, and 3. Notice that the pivot doesn't go into either array, right? So I have 4, 3 in one array, and I have 9 in the other array, and 5 is not in either one. Some people find that confusing. Just keep in mind the pivot doesn't go into either array. Okay? Let's talk about big O. So what's the worst case for a quicksort? Like imagine if this was 1, 2, 3, 4, 5, 6, 7. 7 was the pivot. 7 is the largest item in the array. So that means everything's going to go in the left array and nothing's going to go in the right array. And it's going to keep breaking down that way. So the worst case there is that you get no benefit from the recursion and you end up with n squared, right? Because every item is going to be looked at and compared to every other item in the array. So sorted lists are actually a disaster for quicksort. Same with reverse sorted, right? Because you have the same problem where everything goes in the right array. There are ways to mitigate that risk, which you can actually, instead of just saying automatically 5 is the pivot, you could say, I'm going to look at 4, 9, and 5, and I'm going to find the middlemost element and make that my pivot. This is called quicksort 3, in which case you end up with a much better average case scenario of just n log n, right, which is the average case scenario. But the way that we're going to do it today, we're not doing quicksort 3, we're just going to do quicksort. The worst case scenario is a sorted list. What's the best case scenario? The more shuffled the array is, the better quicksort is. So that's both the best case and mostly the average case as well, which is n log n, right? Because not every element is being compared to every other element in the array. So we end up with n log n, just like merge sort, but it has better spatial complexity and technically can probably go a little faster. So some better coefficients. And we're going to do it as a non-destructive version, but it is possible to do a destructive version which has better spatial complexity. So I think the way that we're going to do it, it would be basically n in terms of spatial complexity, but if you do it destructively, you still have to make some allocations on the stack, which would make it log n. Cool. There are some variations of quicksort, like quicksort 3. That's what I was telling you about just before. There are some other variations, but they're almost all variations around how you choose the pivot, because that's obviously pivotal. Ha, nice. It's pivotal. I'm just seeing everyone shaking their heads like, oh dear God, it's too late for a dad joke like that. It's very important how you choose your pivot. So that's where all the variations of quicksort come in. And you can actually check that out on the Wikipedia page. It'll run down a bunch of those variations.